Okay. Assalamualaikum warahmatullahi wabarakatuh. We are from group B8 are going to present about heat transfer by using Gauss-Seidel method. My name is Muhammad Irfan bin Ismail, matrix number 200814.
My name is Muhammad Azri bin Muhammad Azib. My matric number is 201054.
My name is Muhammad Hidayat bin Zari and matric number 200-725.
Okay, next. For introduction, MATLAB is a high-performance language for technical computing. It is an easy-to-use environment where problems and solutions are expressed in a more familiar mathematical notation. In simple words, it is an advanced and more sophisticated version of a calculator that you can run on your laptop or computer. Next. Moving on to project background. The question that our team had chosen is regarding solving Gauss-Seidel iterative problem. We are going to do this in a more simpler way. Gauss-Seidel iterative is also known as method of successive displacement. And the final answer that will be achieved is we will plot the contour and surf plot, and hence will interpretation of data more easily.
Okay, for the engineering problem. Okay, the question is, we will consider studies two-dimensional heat transfer in a square cross-section, which is width times to height in cm, with the prescribed temperature at top, right, bottom, and left surface to be 100 degrees Celsius, 200 degrees Celsius, 300 degrees Celsius, and lastly 500 degrees Celsius respectively. Using a uniform mesh size, which is delta x is equal to delta y, which means the length is same, we were required to determine the finite difference equation iteration, and B, the model temperatures with Gauss-Seidel iterative method. Okay, next. Okay, so this at steady state, time derivative are 0. According to the formula, delta 2t over dx to power of 2 plus 2d squared times t over dy squared equal to 0. So this is the expansion of the equation. As the delta x and delta y is same, which is equal to h, we can make the equation which is Tij equal to 1 over 4 in bracket Tij minus 1 plus Ti minus 1j plus Ti plus 1j plus Ti times j and plus 1. Okay, next.
Okay, for the script file, we will use the script file as below to solve the problem. First, it will ask the user to input the number of nodes. Basically, number of nodes is to make the calculation become more smooth, while the W and H is the width and the height for the square sample. A, B, C, and D is the temperature of the top, bottom, left, and right respectively. And so T0s is we will use to make the empty matrix to solve boundary condition. And the boundary condition is like this, where T, I will top, bottom, and left, top, bottom, left, and bottom. Top, bottom, left, and right. I'm sorry about that. Next, we will correct it after. So we will use also the while loop to make the calculation become more clearer. And for the figure, we'll use the subplot and three subplot. First, we will get the answer for the contour. Second, for the surf. And the third is the surf also. But the surf for the second is we want to see the 2D structure. Okay, let's see for the result. Okay, this is the result. As I said earlier, when the node is more bigger number, it will make the carrier view. As if we use the low number, it will like we can see the crack of the curve, like zoop, zap, zap, like that lah. And next the subplot 312, the temperature state serve for 2D. We see the view at upper state, and the lastly is the subplot in the 3D view. Okay, that's all from me.
Okay, now after we have finished to answer the question, we are going to move into discussion part. Gauss-Seidel iterative method is a technique for solving the n equation of linearly system of equation ax equal to b one at a time in a sequence and use previously computed result as soon as available. The characteristic of Gauss-Seidel iterative method is the computation appear to be serial and the neo-iterative depends upon the order in which the equation are examined. Next. This is the step-by-step to do in MATLAB, which is we input the number of node, width and height of the 2D structures and temperature at all sides, and then and the number of node will represent for the smoothing of curvature. The higher value, the higher number of node, the smoother the graph will be. The width and height of a 2D structure that we enter can either be rectangular or square in centimeter.
Okay. So for contour, which is at subplot 3.1 before, a curve along the function that has constant value. It shows us the points where the changes of temperature occur. And then for the second graph at the figure before, surfplot 2D. It shows the top view of 3D surfplot. It also helps to detect the changes of temperature from this graph. And lastly, surfplot 3D, which will show the detail in 3D image about the changes of heat transfer. Okay, next. Lastly, for the conclusion, MATLAB is an incredibly useful program for engineers as it can solve real-life problems involving matrices and others in no time at all. With the help of MATLAB, we could perform extensive data analysis, also visualization of the solution for our problem by plotting the graph for the temperature of steady state due to heat transfer by contour, top view, and standard 3D view. And lastly, mFile in MATLAB is the transfer of file to other programming software or to run the file on other computers.
Okay, now for the clearer method, let we run the heat transfer file. Okay, first enter the number of node, like we can say about 50 is such a big number, right? So the width and the height, if as like from the question, you said 3 by 3 centimeter. So at the top, we will just use this and this value respectively. At the top is 100 degrees Celsius, while the bottom 300, left 500, and last but not least 200 degrees Celsius. And it will run the M5 and we'll get the answer, the figure, the three subplot. This first is contour, second is surfplot in top view, and last but not least surfplot in 3D view. Okay, that's all.